Thank you. And yeah, when I was hearing the question, I just started smiling because I just said, yep, oh, I understand this very well. This is the reason why I want to talk about this, but I'll just say I'm no expert. I'm just talking about my experience and trying to figure this out. Because this, as Hillary was saying, like this field is so new that we're all just figuring out where things fit and how we're gonna build these applications that can help and transform people's lives. So bear with me, I'll just go through the journey that I've been through and hopefully everybody learns something. So just quick on my background. I was an electrical engineer, got into software engineering, and I eventually made it out to the high school. I was a MIMS alum, and yeah, I was a MIMS alum, and then basically I decided to join Ancestry, and I was actually a front-end developer for a certain period of time, working on their content management system, where all of a sudden I heard about, there was like, okay, we have this DNA product that like, we want people to like, put, send the spit kit, and we'll basically we'll be able to find out like their ethnicity and how related they are in the, with the database that we already have. So we have this prototype, but I think we need some engineers. We're just going to go to all these different departments and say, hey, can you spare an engineer? Hey, can you spare an engineer? I wish I was joking, but this is what happened. So my boss came to me and said, hey, so listen, we think you're the most engineer that's versatile for change and can kind of operate in different developments. We know that you've been working on front-end engineering, but how about trying this out? And I'm like, okay. So 3 years later, and we've built a pipeline that was able to process DNA for tens of thousands of samples per day. But before I go into that, let me talk about the overall goal, right? This whole point of Ancestry DNA's purpose is to provide accurate DNA matching and ethnicity results to users. And it's always good to know what the central goal is before we talk about different roles and things of that nature, because sometimes you could forget. You say oh no, I'm an engineer, I must do this. Oh, I'm a scientist, I must do that. I'm beyond this and that, and sometimes the goal, the purpose kind of gets lost, and then you don't know where you're going. So the goal was to provide accurate DNA matching and ethnicity results to users, and that was very important. So what happened was I came in, and they basically had this one server, right, with this Perl code that would run a number of different algorithms that would take the text data, clean the data, and it will match it to all the other people's DNA, which was in a text file, like a big text file. I'm not joking. I wish I was embellishing this story, but I'm not embellishing this story. And it will run, and if anything failed, you had to do it all over again. And basically, they would append the results to that text file. So just make sure you don't have two of them running at the same time, or bad things will happen. So the thing is, it's funny, but the thing is, though, those data scientists developed these algorithms that were accurate. I mean, that were accurate, and they were very amazing, and exciting, that you can take. It's not even, we didn't have the whole genome, genome system. It was a very small subset of data from a person's spit, and you're able to find out how related they are from identical twins up to 10 generations removed, actually. And that was really exciting. They also found out another algorithm that can basically determine your ethnicity as well. So the whole thing is they had the algorithm, they did the research. It's just now, and they have this prototype that works in theory, kind of, right? But they're like, okay, that's great, but if we're ever gonna wanna go out into the public and let people really experience this, we need to transform the system into some sort of system that works for people, works for incoming data coming in. And that's basically where they got engineers and said, hey, listen, we will classify you as data engineers. I was like, okay, sweet. And then they're like, okay, so what we're doing is okay, how do we make this more robust. We had separate modules that say like, okay, we have a module focused on cleaning the data. We'll make it retrievable or make it robust. We'll make sure that if there's errors that it's notified and we can go ahead and fix it. We go ahead and they had their matching and ethnicity modules. We're like, okay, we don't want to run this on one computer anymore. Let's figure out how do we make this distributed? Let it run on 50, 100 nodes. We put in MapReduce. Then we realized, oh, MapReduce is actually not a problem. We introduced something called Celery with Python workers. If you don't know what I'm talking about, that's not a problem. But the whole idea was, even though I had no idea what the DNA scientists were doing, even though I did learn a lot during the process, and I'll talk about that a little later, I had the expertise to make a robust system. I know how to take data in, do some stuff with it, and take data out. So therefore, I was able to just help out with this team to take this prototype that's very promising and make it into a robust system that now I think there might be up to 10 million in their database, and it's probably growing because I've been away from there for a couple of years now. But yeah, so that's the power of what a data engineering can do. Essentially, the main thing is extract, transform, and load. Data engineers, at least from my experience, you're building robust systems that work in a variety of situations that take data that that has been defined as the right and best data to do the analysis for. You write you build infrastructure and you write algorithms that takes that data and transform it into the form that you would like. In this case is take the raw, the DNA data and run the matching and ethnicity modules to a format that we can then load or send to downstream systems in order for them to see the results of the transformation. And I say extract and transform, but the thing is that it's not like I told you, I didn't know anything about DNA until I got to Ancestry. I'm not doing any research. I don't know how they even came to these algorithms. It actually took me a while to really even understand how the algorithm worked. But what I was focusing on was, how do I make this more efficient? How do I build the systems necessary to be able to run this pipeline for as many users as we get from the lab that we get information from? I'm able to focus on making this operational, make this production ready, make sure that everything is good. And I was able to sit with data scientists. Actually, Ancestry did something really cool, was that even our seeding arrangements, we were called the DNA pipeline team, and then they were called the DNA science team. And they basically, in every group, they would have 3 engineers, 3 scientists, 3 engineers, 3 scientists. So we literally had to look at, we saw each other every day. So when I had a question on what does this matching algorithm do, okay, I see this weird something that was in R, and I was like, what is this? I don't know what this is. I mean, but and there's no way I'm gonna run 100,000, 20 nodes running this R thing. It's going to break. Tell me what's going on in here, and they'll come and sit down with us and tell us this is what we're trying to do. I was like, oh, you're trying to do that? Okay, let me write this in Python. Let's actually run this side by side and see if this works. That was actually a big part of what I would do, is the algorithms that they came up with, and they wrote modules that in C and in R sometimes. And sometimes I was like, maybe it's better if we just rewrote the algorithm in a different way, or use it, or re-architect it in a different way. And let's run both algorithms to make sure it's the same. And then we can run the data engineering version. We did that a few times, actually, because sometimes the algorithm itself, the way they implement it, may be really good for, let's say, a single process machine, or when you have 100 nodes to your disposal. But when you're running so many samples at the same time, it's just a different set of trade-offs that you have to make. So we've done that a few times as well. But the connection between what I do and the data scientists were integral to making sure that we're all aligned and with building the right product and building what we needed to do. So what the data scientists wrote, that they sat right next to me. I still remember the head of algorithm for DNA scientists was literally sat right next to me, and we would just have like, maybe we'll meet like twice a week basically to just try to make sure that we're in sync with what we're trying to build, because I want to make sure that if we're building a pipeline that's trying to like get so many, compare so many DNA samples to each other, the last thing I want is to run millions of people's DNA and then the scientists look, because they get the results too, and say, this was wrong, and like, 1% of your results are bad, and we got to redo this again. That's not a good thing that we want to have. So alignment is very important. So the data scientist role, from my perspective, was responsible for selecting the data from the user's DNA kits that best suited for DNA matching ethnicity. I said before that as an engineer, we worry about extract, transform, and load. But what to extract was not my responsibility. What they did was be able to go to the lab. They went to the lab and designed the chip to make sure they just select the best pieces of DNA that was good for this algorithm. I didn't have to worry about that. Because they had the expertise to figure that out, and then they'll come to me and say, hey, listen, these are the different versions that we have. This is the reason why we made these decisions. This is how you can maybe fine-tune the cleaning algorithm to make it better. We're like, good, great. So I knew how it worked, but they were responsible in their process to figuring out what right data to bring in. So they found ways to clean the data, and I also overheard that cleaning the data is a very interesting part that nobody wants to do, right? No, the data engineering doesn't want to do it. The data scientists don't want to do it. So what we did is just like, we had a shared pain session of like, okay, we know we're going to have to do this, so let's figure this out. They wrote part of the algorithm. We wrote part of the algorithm. And we kind of just got that going. It was like a partnership between like an engineer and the scientist. They sat down and wrote it together. So we spread the pain on that one. So, and then though, they get the data, they explore the data to find new insights. So they're looking through, doing that, using all the tools that they use to gain insights. And sometimes it's to improve the algorithms, and sometimes it's to come up with a new product. One thing that came out, I think it was 2-3 years ago, is DNA communities. And basically the community was that they found that there was a number of people that had like similar DNA. They weren't like related to each other, but they were related to each other more than other people. And it was just like, why? And they found that like these communities, you can kind of sometimes directly connect them to something that happened historically. Like let's say if a number of people from Poland emigrated to the United States, 200 years ago, they can see that, hey, listen, we think you are part of this group because they saw similarities. They came to that insight by exploring and saw that there was there was clusters of DNA for random reasons, and they knew it wasn't about familial ties or something else. So they just kept doing more research and exploring, getting more data, and then since Ancestry also is about finding out your ancestry, you have access to historical records and stuff. So they were able to connect what they're seeing with these clusterings to actual events in history, and then that became a new product. And I'll just say a quick side about like Agile and things of that nature. This is why, like in Ancestry, the DNA scientists operated on their own timetable, and the engineers operated on their own timetable, because they did the research they had the time to figure out and find this insight instead of saying, hey, we need a product now, we need a product now, we need a product now, because we all knew that without the insight, we don't have a product at all. So it is best to just hire the best people and trust them, that they're gonna come up with something that works, and they have and done it time and time again. So they find patterns to model the data based on those insights. Like, for instance, they just said, okay, if we know these clusters, how can we find a way to quickly have a new DNA sample, be able to say, oh, I'm part of this community. And then they use models to refine the algorithms that inform this knowledge that, oh, you were part of that Polish immigration in 1865, let's say. So their framework, from what I saw, is that they obtain new data to gain these insights. They scrub the data to make sure that their analyses aren't based on bad data. They explore. They take the time to explore the data to find out what new insights they can see. Sometimes they maybe obtain more data, because of course this is an iterative process. Scrub it and explore with that. Then they model what they see, and they find ways to interpret it to inform knowledge. And this is a cycle that continues over and over again until you come up with something like, oh wait, these clusters are actually communities that we can tell users more about their history, about their ancestry. And at that point, that's when they start talking to, like, even though engineers were actually involved with a lot of their exploratory process, they let us know that this may be coming. And sometimes they might give us. We have a lot of times where we share knowledge, because one thing that's shared is that we both program. Both of us program. So actually, what happened is that I actually did a couple of sessions teaching them about Git source control, because I said, hey, listen. They have Python files all over the place and all this stuff. And I was like, hey guys, this has been solved. Let me just tell you about this. This can help you out. And they're like, oh my goodness, this is amazing. So it's like, because there's this like they have this advanced knowledge of one avenue, we have this advanced knowledge of another avenue, there's intersections, and that's when we can help each other out to do each other's job better. However, there are different roles for a reason, because they have that. Because since they have the ability to research and find new insights, they can do that, and then they don't have to worry about figuring out how to put it into production, because that's a whole nother set of skills. So, therefore, that the vision of labor, the data scientist is focusing on obtaining the right data, exploring that data, and building models and algorithms that help inform those insights. The data engineering roles focus on implementing models and algorithms developed from insights to run at scale in a timely, robust, and efficient manner. One thing I will say this, prototypes come here, but the implementation is not the prototype. And time again, you get a prototype running, it works, oh, it's done. No, it's not done, because that thing is broken. It's going to break, it's not gonna run at scale. That's why you have the engineer to make it run at scale, while the scientists can look for the next thing. That's the other thing. When you have data engineers focus on production, that frees up the data scientists to find out the newest research. So by the time we're done, they have like version 2 lined up. And that's actually kind of how that works. And it's a really great partnership, especially when the data science and the data engineering teams are together and they know each other and they interact with each other often. You can have this synergy. So what's interesting is this whole concept of separating science, the science part from the engineering, or research from implementation, is prevalent in almost everything that we do. So I have this thing I'm working on. It's called Keto Exchange, and Keto is so I'm a first generation immigrant from Nigeria. I was born in New York City. My brother and sister and my mom and dad are from Nigeria. And the Yoruba tribe, Keto means to learn from or to teach. It's the same word, actually. So the idea is that, like, how can we figure out how we can learn from each other? A conference is a great way. We're learning from each other through conferences, but how many of us are in alumni networks and stuff that we know that we have a lot of people that we know we can connect with, but not a lot of means to do this? And this is a problem with alumni networks. It's a problem in corporations that like to roll out mentorship programs, basically, that are just that are very honest, because you have this mentor that comes in and say, hey, I want you to be a mentor for this young engineer. Please dedicate half your time to them to raise them up. And there's not going to be a lot of people who neither have the skill set nor to do that. So I just said, okay, I just started looking. I was like, let me read Harvard Business School and see what's out there. So the whole process of that is there's a number of people that have already done this research. They got the data. They did the experiments. They looked at it, and they found, and this is a quick search. This is not that much work, that they're like, hey, short coaching relationships work. That single measurable goal between that short experience, that is really effective. That's paired under a common domain, like let's say project management. That works. Within a trusted network, like an alumni network. This is something that literally, if you look up coaching relationships and mentoring relationships, what's effective, you'll see 10 articles that say the same thing. This is the science part of it has already been done. So it's just that what I was thinking, I was like, okay, I already have this insight. Why don't I just, let's build an application that pairs people up within these alumni networks and make it really easy to do so and give them resources to make it easy for people to pair up, because as you know, everybody has such different experiences, something to offer, but a lot of the times people don't think that they have the ability or expertise enough to actually share. Like, if you think that I was a natural born speaker that can just speak all the time to people, you are very wrong. I had extreme public speaking anxiety pretty much all my life, but nonetheless, everybody has it in them to be able to impart the knowledge that they've gained from whatever situations. Same thing with the data scientists and the data engineers that I was talking about. They both have expertise that they can help each other with. So basically, you know, in this situation, the scientist part is done. I'm just building something that implements the findings that have happened. But it's still the same dichotomy that you see, that when you do something like when you separate the research from the implementation, not that they are in two different worlds and never talk to each other, but I'm talking about the expectations, the skill sets, the roles of people that are playing. When you separate that from implementation, then you really get a ability to implement the best ideas that you have at your company, in your school, and in whatever organization that you're in, because you allow the research the time, the research part to actually explore what the data really is and not be so hard on, this is a product, you need to get something by X. As you all know, when it comes to the incentives, if you have an incentive, you're gonna meet it, but it's going to come at some sort of cost. And usually that cost is the quality of the insights that you are getting. Implementation, I'll just say this, I don't want to research and find out what the newest thing is. If I did, I'd probably move to become a data scientist. What I enjoy is finding out something really cool that people have figured out and say, okay, how do we get this to market? How do we build this something so that people can use right away? So therefore, that's why I'm a data engineer. Well, I found out I was a data engineer. I didn't really know until I moved. Like, I'll be very honest. I did not know until I moved to my current job at Nuna, started for a few days, and then noticed that I'm in the data engineering org. And I said, what? Wait, what's that? And I was just, until I knew that data engineering was a thing, and I was one of them. I was like, it's good to know. I should go look some stuff up, right? So again, to reiterate that this field is still new, but it's very, very exciting and open for a lot of growth. And with that, do you have any questions?
Nice talk, thanks. So question for you is it practical to expect data scientists to write production quality code? And the reason I ask it is because in where I work, we have machine learning engineers and AIs. By the way, the data scientists where I work, they don't like to be called data scientists. They like to be called AI scientists.
Yeah, I've heard that. Yeah.
So question is, we're trying to see if we can actually get them to write production quality code, so they're all part of the sprint and they understand production concerns and reality. For example, they might be trying to use a package that is not licensed to be used in a product, and they end up doing research using that product, and we end up not having to use it. So what are your thoughts on that?
I have mixed thoughts. I think it's hard to say a data scientist, I need you to write this entire application that basically is production ready, that has all of the bells and whistles to come into it. I just told you that our great the data scientist ancestry weren't using Git. So if they're not using a source control, it's going to be hard for them to really be able, at least in my opinion, there are different opinions in this, to have a ready-made application. However, I do find that a lot of a lot of what DNA scientists are writing in code are usually functions. And it's usually kind of begs to functional programming. You have inputs and you have your outputs. I do think that DNA scientists with some training can write functions that are that are pure functions, no side effects. You have your inputs, they run it, and it has an output. And actually, one of the DNA scientists developed this ability, and we literally were able to, the matching algorithm, we're able to take his C code and use Python libraries to call it directly without modification. So I do feel like on the functional level, I believe it's possible. It's just that when you get to applications and then downstream dependencies and things of that nature, that's when it becomes harder and harder, I think, to ask that. But that's just my opinion. Yep.
Other questions?
Can you talk a little bit more about the challenges when you talked about the scientists had other languages that they were using, such as R and C. Can you talk about some of the challenges for you that you faced working with those folks because of those languages?
Oh yes, it's. I mean, it's hard. I mean, because you end up having to learn it. But as an engineer, learning new languages, that's kind of something that you're trained to do. But learning R, especially, that's hard. That was hard. So it was just. It was hard, but what was good is that since we had a good relationship, I had a good relationship with the data scientists, it was just, you sit down, I sit down, then what does this mean? What does this mean? I mean, it came to that, because I was like, I need to know every line of code if we're going to re-architect it and write it in a different language. So yeah, it's painful, but then once you do it, though, it's so much more beneficial. And I believe they started using, the scientists started using the engineering version for running as well. So now there's only one code base. So yeah, it's a painful process, but it's beneficial to go through that experience when you need to move to another language.
Okay, let's take one right at the back on the right there. Yes, thank you, and then we'll come into the middle. Thank you.
Can you talk a little bit about how you were able to sort of foster the positive relationship that it seems that you've had between the data engineers and the data scientists? Because I find that that's hard in many organizations.
Yeah, no, great question. I really do think, especially the moment I even started, it was all about, hey, we're in different organizations, but we're one team. So we need to understand that we're working in tandem. And a lot of times, the one thing that was really beneficial was that the scientists would hold brown bags and say, hey, listen, let's talk about what these algorithms are actually doing. They will sit us down and talk to us about DNA. And this is probably one-on-one that they learned 15 years ago, but they took the time to talk to us about that. And then we, in turn, sat down and talked about the basics of our craft that helps them. And I think it was just understanding that, wow, you have great expertise in this, and I have great expertise in that. There was a shared level of respect, and I think respect is a big thing. Is that I think a lot of times I see, I've seen these relationships break down is when one org doesn't respect the other because they're just oh, they just don't do anything anyway. They're not churning out new features, or oh, the engineers, they're just redoing what we just did. When you start to really talk and find out what people are doing, then that level of respect happens, and then I think that was the real basis of the good relationship. No problem.
Okay, let's. This gentleman behind you, yep. We'll take two more questions. So the gentleman in the white shirt there, and then you'll take the last question, and then we'll break.
Thank you for the presentation. In your last organization, was the data engineering team part of a bigger engineering team? And I ask that because some organizations have one team who does implementation and all the requirements, data science or not data science come, and then they have to do the prioritization and implementation. And sometimes the data science priority gets bumped down the list because it's not really production urgency.
No, gotcha. Yeah, and let me just try to remember, because during my time there was a lot of reorgs. But I do think what ended up happening was they created I believe it's a chief scientist officer, which was the data and the C-level executive, and that was the data, and that's where the data science organization came through. And then there was a general engineering org, and that's where my, through that, then it was separated to DNA, and then it was like then the DNA pipeline team. But then there was these like dotted arrows that said, hey, listen, these two avenues need to work like very well together. So we were separate organizations, but the chief of data science was a C-level executive. So it was just very known that this is important to us. Yeah.
Okay, last question. Gentleman in the purple shirt here, if you can come down into the center. Just here. Thank you.
Hi, I do, I guess, data engineering work also, and I kind of found out, I call myself data scientist, but in my group, I also have to manage the hardware itself, and like sometimes I've been on the floor with a screwdriver saying, wait, I'm a data scientist, what am I doing? Mm-hmm. You said you started with a single computer and had to scale up. Who did the hardware part, and how did you interface with that? So,
one, I hear you and my heart goes out to you. First. I fortunately did not have to deal with that. So first, like DNA came, like the DNA product was very like startup-esque within Ancestry, and they literally had a box next to them. But then by the time we were coming in, they're like, okay, we had a data center. It's time to move to a data center. Let's get things provisioned for people. So basically, the data center people would just also, I think we had a few of them just assigned to DNA, and they will help us out with that. But that's hard. That's hard, for sure.
Okay, thank you everyone for all your comments and questions. Kay, thank you so much.